Okay, I'm Jarret Hart. This is going to be one chapter of my dissertation that I'll be talking about today. So I just wrapped up my dissertation in March at Davis, and now I'm currently there as a postdoc. So this is a very large study. It's really 3 studies that I'm going to try to talk about today. So there's going to be 3 parts. The first 2 I'm going to talk about very briefly, and I'm going to spend more time on the third part. So to start off this study, I wanted to ask if alcohol consumption patterns in the US are converging. And the reason why I wanted to ask that is there's a few other studies that have come out recently that have said alcohol consumption globally isn't converging, in the sense that countries are becoming more similar in the mix of alcohol that they consume. And in these papers, so they say that beer drinking countries in general have started to drink relatively more wine and spirits and less beer. Wine drinking countries historically have started to drink relatively less wine, more beer and spirits. So in these studies, they've used the United States as an example of a beer drinking country that has started to drink less beer and relatively more wine and spirits. And so I'm working on this with Julie and Alston, and we thought, that's kind of an oversimplification, and we didn't really think that was the story happening in the United States, because it's a very diverse country. There's very diverse preferences within states, and the categories of beer and wine are very diverse, and they've been changing over time. So we wanted to set out to show that that's not true, and we do. So first thing we do is we show that consumption is not converging. And then once we do that, we want to know, well, what might be accounting for these diverse consumption patterns across the country. So we start off with a state-level demand analysis, and doing this we include a lot of different demographic variables that we think might be tied to alcohol consumption. So we look at religion, we look at obesity, the ancestry of people, income, political affiliation, the urbanity of areas, a number of variables to try to link this to demand. And we do classic demand analysis using a Rotterdam model, and we find that using this publicly available data that's commonly used for this kind of demand analysis, that the model works very poorly. So we are a little bit disappointed by this, but we have access to some better data. So then I decided to do the analysis all over again, this time using Nielsen scanner data of grocery store sales across the country for 2006 and 2016. And now I'm disaggregating. So I'm not looking at state level, I'm doing designated market area level. So we're disaggregating the areas. We're also disaggregating across product space. Instead of looking at a category of beer and a category of wine, now I'm going to look at craft, import, macro beer. I'm going to split up wine into a low price category, high price category, and another category. And doing this, as well as going from annual level to monthly levels, I find that the models perform a lot better, and we have a better understanding of the relationships, and we can get better elasticities from this estimation. So just to summarize the first part of the paper about convergence, is that we find that there isn't convergence. And this picture is going to illustrate it pretty well. So we replicate the estimates of convergence that are used in the Holmes and Anderson paper. And so this estimate right here is going to be the similarity index across states. So it's comparing the similarity of every state in the United States over time to the annual consumption mix of beer, wine, and spirits. So if this index were to say that the states in the country are becoming more similar to each other, then this would be approaching 1 over time. But what's happening is from 1970 to about 1996, it looks like states are becoming more similar in their shares of beer, wine, and spirits. Once we get to 1997, that trend reverses, and states started becoming more different from each other. So now all of a sudden, the similarity index is going down, and what also is happening is the variance across states is increasing. So states are becoming increasingly more different from each other in recent years. So now, what might account for these differences? So first, what I've got here is the ratio of beer to wine consumption in the United States. So a very blue state is drinking relatively less beer compared to other states. a red state is drinking relatively more beer compared to wine than other states. So in the blue, we've got a lot of West Coast states, the Northeast, they're drinking relatively less beer. And then the more heavy beer drinking countries or states are a lot in the Midwest and in the South. So let's compare that just to a few other variables before diving into the analysis. So first, here's education across the country. So once again, you can see some similarities right away. We have a lot of blue states here with high education on the coast, on the West Coast, also in the Northeast area, lower education in the South and parts of the Midwest. Okay, so some similarities. Here's another one. So now we're looking at obesity in the United States. Once again, you're seeing a lot of the same blue states. So where obesity is lower, in the blue, we see that a lot on the West Coast and in New England. And then we have high rates of obesity in the parts of the South and once again parts of the Midwest. And one more variable that we can look at. Here's the ratio of Trump to Clinton votes in the 2016 election. So once again, lots of blue Hillary voters in the West Coast and in the Northeast. And then once again, in the South and parts of the Midwest, we're seeing those very red states. So we have a red state, blue state, Trump state, Bruce state. So those are some fun variables to look at. But the main variable we're interested in is the ancestry of people. So we hypothesized that we might be able to link ancestral consumption of beer and wine to what people are drinking currently. So I created this predictive variable of ancestry for each county or state. And how it works is, let's say there's a county in the United States that's 50% Austrian and 50% Italian. And what we would do is we'd say, okay, well, in Italy, if I want to have the beer ancestral consumption, in Italy, there's 6.3 liters per capita of alcohol consumed. So I multiply that by the beer share of 23%, so 0.23 times 1/2. And then the other 50% being Austrian, we'd take that 10.4 times 0.51 times the 0.5 for the other half of the population. And that would be our predicted beer consumption based on ancestry. So I'm going to see how that relates to beer and wine consumption now in the U.S. So looking how this is how this variable looks across the United States. So this is the beer ancestry variable across the country. So in parts of the Midwest, it's very red. So these are areas that typically have ancestry from Northern Europe, Scandinavia, those types of areas. And in the South, there's a much greater percent of population from Southern European countries. So that's why there's a lot more blue in those areas, because they drink relatively more wine than beer. And when I break that up into the county level, you see that there's a great amount of variation and heterogeneity within the states. So looking in the Midwest, there's some states with lots of red and blue. And then like Texas, there's some very red areas. So this is really just highlighting how important it is to disaggregate the data. Because if you're just using the state level analysis, it could give you a completely different result than if you're using county or market areas. So just briefly, the model, it's going to be in 2 stages. First, it's just a single equation demand model. So the only thing I want to note with this is that typically this demand models are going to be log difference from one period to the next. Except I want to exploit the spatial variation in the United States. So instead of differencing from one period to the next, I'm differencing from one market area relative to all other market areas in the United States at a given period in time. And then in the second stage of the estimation, it'll be a Rotterdam model. And the reason why there's 2 stages, in the first stage I get Hicksian elasticities. The second stage I get elasticities that are going to be conditional on group expenditure. And then combining these 2 stages, I can get elasticities that are conditional on total income, which is going to be the policy relevant elasticity. But really, I'm just interested in the relationship with the demographic variables, and I'm going to use these elasticities as a check that the model is working well. They're not the main focus. And I only note this bottom part about the 2-stage estimation is because a lot of time in the literature, there's an endogeneity issue that's often ignored with having the Divisia quantity index on the right-hand side and the left-hand side having quantity. So we correct for that. So instead of going through all the state level analysis, I just want to give you the takeaways. So what I find is that the estimation is very fragile. So it changes based on which demographic variables I include, whether I include any of them at all or all of the variables of interest. And part of this issue comes from is that I'm aggregating at a very high level. I am using states that are very diverse. I'm looking at annual data. I'm aggregating product categories in which there's craft, macro, and import beer, but those are very different categories, and it's changed a lot over time. So it doesn't really make sense to be doing this. However, in the literature, this is publicly available data I'm using, and it's very commonly used to derive elasticities. And they often ignore these issues completely, and so they also tend to not be clear which elasticities they're presenting. If it's a elasticity conditional on group expenditure or an elasticity conditional on total income, and that completely changes the interpretation. So we decided to set out to be very careful with the elasticities or reporting and to make sure that they're robust across specification. So after doing this and finding these shortcomings, we move on to use our Nielsen scanner data. So here's just the disclaimer because it's copyrighted data. And now this is going to span from 2006 to 2015. So the data, I start with more than 2 billion observations of weekly UPC-specific sales data for 270 market areas in the United States. And then I'm going to aggregate this data so that I have monthly observations of sales, and they're going to be for 3 categories of beer: craft beer, macro beer, imported beer. 3 categories of wine: low price dry, high price dry, and other wine. And then, since not all areas in the United States can sell beer and wine in grocery stores, we end up with only 181 market areas with beer sales and 182 market areas of wine sales. And then we end up with about 20,000 observations in total. So first, what I have here is going to be the second stage estimates, the elasticities from the Rotterdam model. And I'm not going to dwell on these too much because once again, this is just a check to make sure that the model's working, and these aren't the policy relevant elasticities. But looking down the diagonal, the price elasticities, they seem pretty reasonable. There's nothing too strange happening. I have a lot of complementarities, substitution effects, as well as complementarities between the different product categories. So I'm feeling pretty at ease with these estimates. And I found that these estimates didn't change much based on whether I included or excluded demographic variables. So far, I'm pretty happy with these estimates. So now let's look at what I am interested in, which are the demographics. So in the first line, I have the Trump variable, the percentage of GOP voters in a market area. And so what do I find there? Well, I find that Trump voters have an increase in demand for macro beer, areas with Trump voters, a higher percentage of Trump voters, and a lower demand for all other categories of beer and for wine. And then when I look at my main variable of interest, the ancestry variable, so starting with beer ancestry, I find that areas with historically high beer ancestry are consuming relatively more craft beer and more macro beer, but relatively less imported beer and less low and high priced wine. And then looking at the wine ancestry variable, I find that actually surprisingly, areas that have high wine drinking ancestry are demanding relatively more craft beer, as well as more imported beer and more low priced wine, but they're demanding relatively less macro beer and high priced wine. So some of those were a little bit surprising. And then since Hispanic ancestry is typically a little bit different than European ancestry in what they demand for alcohol, I put a control in for Hispanic populations, and I find that Hispanic areas are drinking relatively more imported beer and relatively more low-priced wine. And then I also have a population density variable in this specification, so more urban metro areas are drinking relatively more imported beer and high-priced wine, and less craft beer and less low-priced wine. So now the policy relevant elasticities, which are what I want to compare to the literature. So going along the diagonal, I find that craft beer and imported beer are much more, the own price elasticity of demand, it's much more elastic in comparison to the macro own price elasticity of demand. And then also the high price wine and the high price wine elasticity of demand is also much more elastic compared to the low price and other wine categories for the own price elasticity. And then the income elasticities, I find that the income elasticity is much higher for high priced wine and other wine than it is for all categories of beer and low priced wine. But within beer, I find that the imported category and the craft categories all have a higher income elasticity than the macro category. In comparing this with the literature real quick, with a meta-analysis that was done by Fogarty, I find that our variables are our estimates are very different from the literature in some cases. So our beer own price elasticities generally fall in the same range as the literature, and they are robust to whether or not I include demographic variables. They're a little bit lower, a little bit less elastic. And then looking at the wine own price elasticities, I find that these are actually much higher. They're much more elastic in comparison to what's being reported in other studies. And this is the same for the income elasticities that I find for beer and wine. So the conclusion from this part of the study is that it's very important to use disaggregated data. You're going to find much more consistent results if you're deriving elasticities. And in general, you can't really trust analysis as much if you're aggregating at too high of a level. And this is going to translate to if you're doing studies in other countries. You want to be sure to be using as disaggregated data as possible. And I find very strong evidence that's linking alcohol consumption to the ancestry of areas as well as political affiliation, the urbanity of areas, among other variables. And just to highlight once again how those ancestry variables link to consumption, beer drinking areas or areas with high beer drinking ancestry drink relatively more macro beer and craft beer and less of everything else. And then areas with high wine drinking ancestry drink relatively more craft beer and low priced wine and imported beer and relatively less of the other categories. All right, thank you, that's it.